Good morning. Today we're going to solve these radical equations. So I'm going to work these out for you in case you were absent or you were confused or something like that. So this was your homework that it was assigned on Friday. Okay, let's look at number 1. All right, so we're going to go through our steps. We're going to isolate our radical, and it looks like it is, so that's done. And then we're going to do the inverse exponent. So the inverse exponent for a square root would be a square. So we're going to square both sides. So that's your inverse exponent. All right, let's go work that out a little bit. All right, the square root and the square are going to cancel each other out, and we're left with 56 minus r is equal to r squared. And now we're going to solve the equation. Now, when you're doing a quadratic, there's some extra little bullets that we might want to take care of. Okay, you want to set one side equal to 0. So this is a little bit special, so I'm just going to put some sub-captions in here. So let's go set one side equal to 0. We're going to add r here, going to add an r here, and we're going to subtract 56 here. Okay, so this side is 0, and this side is going to become r squared plus r minus 56. Now, you're either going to graph or you're going to factor, but you're going to solve the quadratic. Okay, by either, if you graph it, you're going to see the solutions. If you factor, you're going to have to go and solve it and set it equal to 0. So let's factor it first, since we're in advanced algebra 2. We want to find factors of negative 56 that add up to 1, because that's a 1 right there. All right, so I'm thinking it's going to be negative 7 and 8. So we're going to do x minus 7, x plus 8. Go ahead and pause right now and write these steps down if you need to, because we are going to go, I have to erase them. I need more room. All right, so I'm going to erase them in a minute. Let's go ahead and solve it. We got x equals 7 and x equals negative 8. All right, I'm going to go erase these steps because I need more room over here to write it. So we solved the quadratic. We have 2 answers. Now we need to go and check for something called an extraneous solution. Okay, extraneous means it's extra and it doesn't work. So we're going to plug it back into our equation, our original equation right here, and see if it makes sense. Now remember, anytime you have a square root, you need to have a positive answer. So let's see what happens. So we're going to take 7 first. We're going to put in 56 minus 7. Does that equal 7? I'm just putting the 7 in for the r. So 56 minus 7 is the square root of 49. Square root of 49 is 7. So that works. So 7, x equals 7 is definitely a good answer. Let's go plug in negative 8. So square root of 56 minus negative 8 is equal to negative 8. So that's the square root of 64 is equal to negative 8. Technically, yeah, negative 8 works, but you want it to be a positive 8 here. So negative 8 is an extraneous solution and it doesn't work. So the only right answer is 7. All right, let's go work on number 2 for a second here. Change colors. Same steps. Go ahead. You got your radical isolated, so let's square both sides since it's a square root. And we get negative 10 plus 7p is equal to p squared. We have to solve it, so let's set one side equal to 0. I'm going to add 10 here and subtract 7p, and I'm just going to move them to the other side. So we're going to end up with, hold on, I got something going on here. We're going to end up with 0 on this side. It's equal to p squared minus 7p plus 10. Now you either factor or graph it. If you graph it, you're going to get the answers. If you factor it, remember you got to change the sign. So we got p and p, and we want factors of 10 that add up to negative 7. So I got 1 and 10, 2 and 5. All right, so I think negative 2, negative 5 is going to make negative 7. So negative 2, negative 5. That still equals 0. Okay, so I'm back. I had to pause that for a second. All right, so now let's say, well, we know p minus 2 could equal 0 or p minus 5 could equal 0. So basically, p is equal to 2 and p is equal to 5. So go back and check for your extraneous solutions. Plug them back into the original equation. So we've got negative 10 plus 7 times 2, square root of that, does that equal 2? So that's going to give us the square root of 4 equals 2. Well, that works. So that's going to be a right answer. And then we've got to go plug in positive 5. So let's go plug that in. So we've got negative 10 plus 7 times 5. Does that equal 5? So that's the square root of 25. Well, that equals 5. So that'll work too. So both of those answers work. We don't have any extraneous solutions. All right, let's go on and look at number 3 and 4. I'm going to have to erase these. All right, let's go and check these real quick. Now, these get a little harder. All right, so I'm going to square both sides. So, you got to square the whole thing. This becomes 2v minus 7 equals, now this is v minus 3 times v minus 3. Because remember, v minus 3 squared is v minus 3 times v minus 3. It is not v squared minus 9. All right, so, oh, I messed up. I've got to go and when you square a square root, oh, I made a mistake, right? That's 2v minus 7. It's not the square root of that. All right, let's go and FOIL this. You got to FOIL the right-hand side. So FOIL and multiply or whatever you need to do. You're going to end up with v squared. Once you work it all out, you get minus 6v, because it's minus 3v minus 3v is minus 6v plus 9. 2v minus 7. All right, let's keep going. I'm going to make this page longer. All right, so now you've got, I'm going to work it all out because I got to pause it. Well, no, I can't really pause it for a second here. All right, so now we're going to go and subtract 2v and we're going to add 7. So we're going to end up with 0 over here. We're going to subtract 2v and we're going to add 7. So we end up with v squared minus 8v plus 16. So you want factors of 16 that add up to negative 8. Well, that's going to be negative 4, negative 4. Okay, well, really, so now v is going to equal 4, right? Because all that has to equal 0. So v equals 4. Let's make sure it works. Plug it back in. And plug it back into this original problem here. So I've got square root of 2 times 4 minus 7. Does that equal 4 minus 3? Square root of 8 minus 7 is 1. 1. Yep, that works. So that works. That answer works. All right, let's go on. I hope I have enough time to finish this. I got one more to do. So v equals 4 is the right answer for that. All right, let me move on to number 4. Now this one's a little different because it's got an exponent. But really, something to the 1/2 power is just the square root. But the big thing we have to do is isolate this guy right here, okay? So let's start by subtracting 5. We end up with x minus 5 is equal to 3x minus 11 to the 1/2. All right, now we're going to go and undo that by doing the reciprocal of 1/2, the exponent, and that's going to be a 2. So raise that to the 2nd power. All right, so remember, x minus 5 squared is really x minus 5 times x minus 5. And that's really, these two guys are going to cancel out. And we get 3x minus 11. Time to FOIL. So let's FOIL all this. And you get x squared minus 10x, right? Because negative 5x is negative 10x plus 25 equals 3x minus 11. Combine your like terms, so subtract 3x and add 11. Subtract 3x and add 11. Let me make this page longer. All right, so I've got one more thing to do. I'm going to do x squared minus 13x plus 26 is equal to 0. So you want factors of 26 that add up to negative 13. I don't even know what that's going to be. Factors of 26. You got 1 and 26, 2 and 13. Did I do that right? No. Yeah, it looks like I did it right. Check that. This could have no solution. Hold on, let me see. 3x minus 11. Looks right to me. Yep, it looks right. So guess what we're going to have to do? I think we're going to have to do that quadratic formula. So we're going to do this in class together, okay? So if you got something where you thought it was no solution, you really do have a solution, but you just have to use the quadratic formula, okay? So we'll do that in class.